Let us discuss about electric potential V equal W by Q. Here W is the work done on the charge, Q is the charge, and V is the potential. So now let us write the units for them. The W is measured in joules, charge is measured in coulombs, and V is measured in volts. Volts also we can write joule by coulombs. Next, electrical potential due to point between the points in an electrical field. Means if you consider 2 points in electrical field, we can find out the potential difference between them. Let us see that. Here potential difference equal to the work done by charge. So the potential difference means final potential minus initial potential equal to W by Q it is. Next, work done equal to the potential difference into charge we can write. Now electric potential at a point due to a charge. Due to charge, how to find out electrical potential at a point? So that let us consider a charge and it produces an electrical field E. On electrical field, there is a point P. R is the distance between the charge and point P. At P, how to find out the potential? V equal to question mark. So V equal to 1 by 4 pi epsilon naught into the Q by R. Q by R. R equal to distance between charge and point P. R is the distance between charge and point P. The next one, let us find out the potential due to electrical dipole at any point. How to find out? Let us see that. Here V equal to formula 1 by 4 pi epsilon naught into P cos theta by R square. P cos theta by R square. Here the P is the dipole moment and R is the distance between charge and point P. And let us consider electrical dipole which has a negative charge and a positive charge, and both are separated by a distance 2a and O is the center. And now let us consider a point P. And now draw a line from O to P, and here R is the distance between the O to P, and it is making an angle theta with length of the dipole. Now R is the distance between O to P. R is making an angle with length of dipole. Now for an axial line, theta equal to 0 degrees. So let us consider a dipole. O is the center, P is the point on axial line, R is the distance between O to P. At P, V equal to 1 by 4 pi epsilon naught P by R square. P by R square. P by R square. P by R square. Next, let's find out for equatorial line. For equatorial line, potential is equal to how much? Let's draw electrical dipole. O is the center. Draw equatorial line. R is the distance between them. At PV equal to 0. Now, we are going to discuss about electric potential at a point due to system of or group of charges. Let us draw a straight line. Let's consider origin like it is x-axis. There are charges on a straight line like Q1, Q2 and Q3 and so on. You can arrange the number of charges on a line. Now here, so what is the distance of a charge from origin? That is R1. R1 is the distance between O and Q1. Like similarly, R2 is the distance between Q2 and origin. R3 is the distance between Q3 and origin. So here the total potential can be found out at O, V, Vt equal to V1 plus V2 plus V3 and so on. V1 due to Q1, V2 due to Q2, V3 due to Q3. So we write the formulas also. V1 formula 1 by 4 pi epsilon naught Q1 by R1 plus 1 by 4 pi epsilon naught Q2 by R2 plus and so on we write. This is how we find out the total potential due to group of charges. Next, let us discuss about the null point. Null point is also called zero potential. Let us discuss about for like charges. Like charges means similar charges. Plus Q1 and plus Q2. like charges plus q1 and plus q2. Now P is the null point where potential is 0 and there is a distance between P and q1, that is y. Y is equal to formula d. What is a d? Distance between the q1 and q2. So d by q2 by q1 plus 1, q2 greater than q1, q2 by q1 plus 1. Next, for unlike charges, what is a null point? How to find out the electric potential? So now let's consider unlike minus q1 and plus q2. There is a distance between them. Null point is outside for unlike charges. P at V is 0. Y is the distance between minus q1 and P. Y equal formula d by q2 by q1 minus 1. Null point is always close to smaller charge. Next, let us discuss about the relation between electrical field and electric potential. First formula, E equal to minus dV by dr. Here minus dV is the potential difference between 2 points and dr is the distance between 2 points. And another formula, E equal to V by R. You can also write in this manner. Now another formula, in vector form we write electrical field in components. How? Let us see. Minus dV by vector dr, and this is the one formula to find out electrical field in vector form. Here vector E we write in components. Vector E equal to Ex I cap plus Ey j cap plus Ez k cap. Ex, Ey, Ez are components. Next, vector dr we write in components. Dx I cap plus dy j cap plus dz k cap. Now we can find out the components of electric field. Ex equal to minus dV by dx. Similarly, Ey equal to minus dV by dy. And next, minus Ez equal to minus dV by dz. This is how we find out the components. Next, another formula. Here potential difference. We write V final means final potential and minus initial potential is equal to minus integral initial point and final point vector E dot vector dr. Here vector dr is the displacement. We write vector r2 minus vector r1 or final position vector minus initial position vector. Let's consider x-axis, y-axis plane. There is a 2 points A and B. We refer from origin. Position of A is from origin is vector r1 or vector ri. Position of B from origin vector rf. AB is the displacement, means A is initial, B is final. Next, similarly, let us consider electric field. In the direction of electric field, potential always decreases. The direction of electric field, potential always decreases. Next, for uniform electric field, formula of E equal to V by R it is, or D, V by D. Next, D is the distance between 2 points. We can also write R. Next,